All right, so the reduction in sales of seven randomly selected products of God group of companies were noted before and after an advertisement. Find a 95% confidence interval of the mean decline in sales of the seven randomly selected products of Goldman Group of companies. So here, what's happening is Goldman Groups had some certain goods for sale. They made some advertisements, and after those advertisements, their sales dropped. Okay, so here, basically, what the question is asking us to find, we have to find a certain range in which the sales dropped. Okay, we set the range in which the sales drop, and then what this 95% means, it means if we conduct this test 100 times, 95 times out of those 100 times, the drop in the sales is going to be found in the range that we calculated. Let me repeat myself again. We want to find the range in terms of quarter of the drop in sales. Okay. So this range, because they're saying with a 95% confidence interval, meaning if you conduct this test 100 times, 95 times, the drop in the sales of this product is going to be found in the range that we are trying to calculate. Questions before we move further? There's a drop in sales, so I want to find the range of that drop. There's a drop in sales, so I want to find the range for that drop. Okay. For example, if find the ranges between 4 kwacha and a 2 kwacha drop in sales, then it means when you conduct this test 100 times, nine, just hold on. If you conduct this test 100 times, 95 times, the range in our drop is going to be between 4 kwacha and 2 kwacha. Okay. If, for example, the range that we find, the range for the drop in sales is between 4 kwacha and 2 kwacha. Sales dropped between that range, 4 kwacha and 2 kwacha. Okay. We find the range. So when we say 95% confidence interval, when you conduct this test 100 times, 95 times, when you conduct the test 95 times, that drop in sales is going to be between 4 kwacha and 2 kwacha. Any number between those amounts. Yes. So there's a yes. Mm-hmm. Okay. Okay. It's very involving. It's very involving. But just remember this: there is a drop in sales. We want to find the range of that drop. Okay. Drop in sales. We want to find the range. Let's get our um, papers and pens because this is yeah, it's kind of involving. So we're going to do it in steps. Okay. We're going to do this in steps. Okay. So step one: calculate the average of the difference of the means. Let me type that out. Step one: calculate the average. Where's this paper? Yes, step one, we calculate. Okay. Step one, calculate the average in the difference of the means. Okay. Because sometimes these can be average also by averages by themselves. Okay. So what I'm basically saying is here, the sales before the advertisement, you're going to subtract them by the sales after the advertisement. Okay. That's what we're going to be doing. Sales before advertisement, subtract by sales after advertisement. Okay. So for this one, it was 14. And after the advertisement, the sales went down to 13. So 14 minus 13, 1. For this next product, the sales before the advertisement, 18. After the advertisement, the sales have dropped to 15. 18 minus 15, 3. This other one, so, sales before advertisement, 21. Sales after advertisement, 20. 21 minus 20, 1. Any questions? We haven't yet found the average. First, we're subtracting. First, you subtract, 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 then you find the average. Any questions so far? So this other one, 15 before advertisement, 15 after advertisement. 15 minus 15, 0. 17 minus 16, 1. Okay. 19 minus 16, 3. 23 minus 21, 2. Right. After you have done all of that, then now we are going to calculate the average. Okay. Remember how we calculate the average? First, you total these up. 1 plus 3 plus 1 plus 0 plus 1 plus 3 plus 2. Divide it by 1, 2, 3, 4, 5, 6, 7. Okay, so the average is going to be, I believe we remember how to calculate averages, right? 1 plus 3 plus 1 plus 0 plus 1 plus 1 plus 1 plus 3 plus 1 plus 0 plus 1 plus 3 plus 2. You total them up and you divide by the number of them. So there are 1, 2, 3, 4, 5, 6, 7. Okay. So when you add these, you get 11. 11 divided by 7, 1.574. That is first. That is our average. Any questions? Subtract the before and afters. After you subtract the before and after, get the average of the differences, and that's step one. Questions? Mr. Langson? Madam Betha, Mr. Foster, Madam Faustina, Madam Hasty, Mr. Casono. Okay, okay, okay. Yes. So that's the first step. You get the difference, the average. Step two, get the standard deviation. So in statistics, whenever you hear standard deviation, it just means how far apart points are from the average. Okay. Anytime you hear standard deviation. So step two begins here first. Here. In this column where you're saying this D with a line on top, this represents the average. Okay, colleagues? This D with a line on top represents the average. Okay, so what you're going to do next, after you've got the average, all right, these differences, this D here, again, I forgot to mention, this D is just the difference between the before and after. So what you're going to do, colleagues, is this D, which represents the difference before and after, you subtract it from the average. Mhm. X bar. Yes, we can use X bar. Colleagues, are we going to, are we okay with X bar? Since there are two D's, so maybe it's confusing, huh? Okay, okay. Okay. I put D. I was just using D for this is for somebody. I'm typing for someone, so I just wanted to look unique. Okay. So X bar is the average, yes. Then D, this D colleagues, it's just the difference that we got when we subtracted before minus after. Are we okay with that, colleagues? This D, a difference for the before minus after. Yes. Average. Yes. So you do. Oh yeah, yeah, yeah. Colleagues, are we okay with that? Otherwise, but I thought D, since D represents difference. So I thought I was under the conception that people would at least grasp that D. Okay. Is everyone else okay with the D? Just remember, it's just the difference. Okay, 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 okay. So, so where was? Yeah, yeah, it will be X. I just like to simplify things for everybody. Mhm. So if you when you're reading a book and you see X, just remember X is just representing the difference. Okay. Yes. So the next part, as I said, step two begins here, where you're subtracting the difference D minus the average. So 1 minus 1.57. Can get our calculators. 3 minus 1.57, 1 minus 1.57, 0 minus 1.57, 1 minus 1.57, 3 minus 1.57. Okay. You don't have to use as many decimal places as me. Okay. I was using Excel, so it was just giving me the full decimal places. If you want to make life easy, just leave it to two decimal places, okay? Yeah. Yes. Then use 2 minus 1.57. Are we all clear with that section? Okay. After you subtract the difference from the average, you square. Okay, this is this last column here. When you subtract the difference from the average, you square. So negative 0.57 squared, it will give you this. 1.42 squared, it will give you this. Negative 0.57 square, it will give you this. Negative 1.57, negative 1.57 square, it will give you this. And so on and so forth. Any questions? If, wait. So your question is if there was supposed to be a negative value and you forget to put it. Uh, yeah. Oh, mm, let me see. 1 minus 1.57. It gives a negative. It's supposed to be negative, yes. Sub. Yeah, you're starting with this one here, then subtract. Remember, yes, d minus x bar. Yes. So if your calculator was doing that, don't even enter the exams with it. Okay. Okay. So after you've squared these values, get the total. Okay. You add them up. After you square the values, add them up. This plus this plus this plus this plus this plus this plus this. Okay, you get 7.714286. Uh, Table B, it will make life easier. It will make life easier. I know you won't lose marks. Huh? The thing about just if you're not using a table, how can I say? You might make a mistake somewhere, somehow. So I'd advise just use a table. Yes, just use a table. No, 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 no. We're not yet done. Have you copied down? Just get a screenshot. Okay. So this is the formula to get the standard deviation. This formula also be provided to you. It's the same standard deviation formula that's used out throughout statistics. So yes, sigma, meaning the summation. Okay, meaning this number here, it's the total for when we're subtracting when we're squaring the d minus x values, x bar values. Okay. So this top part here, we've already calculated it. Okay, colleagues? It's this, yes, it's here. Okay, and then n is just the number of items. Okay, number of variables, number of items. So in this case, it's the number of products. So one, two, three, four, five, six, seven. So n equals seven. Okay, n is just the number of items being studied or the number of variables. Okay, so n equals one. Huh? N equals seven. The root of everything. Yes, yes, yes. It's just that the way this square root has been shown. Maybe let me just put it in a proper way so that so it's the root of everything, colleagues. Okay, not just the top number. No, yes, not just the top number. Yes, like this. Mhm. So do 7.714 divided by 6. Then get the square root of that number. Are we getting 1.13? Okay. Are we okay with this? Any questions, colleagues? Any questions, queries? Anyway, there will be a question for you to try after this one, so you'll be able to gauge. Now we're done with step two. Yes. Ah, show it in the exam paper. Remember, mathematics. If yes, is a procedure. Yes, basically, what's in this formula is the procedure. This top part here. So, madam, please show them in the exam. Okay, your workings, show them there. Okay. Yes, because if you just come like if you just put it like this, you lose a lot of marks. You might even be, you might think you are even copying. Eh, unless you're very good at guessing. Okay. All right. So that is step two. Get standard deviation. Okay. Step three. Get the critical value. Okay. So how we get the critical value? All right. We You take note of your confidence level. It will be always given to you in the question. But in real life, it's you who has to choose your own confidence level. Okay. Basic confidence level, how sure you are. Okay. If you've got a 99.9% confidence level, it means you are very sure. It means if you conduct the test 100 times, 99.9 times, you'll be getting your values or your hypothesis. So here it's 95%. Okay. For the critical value, first take note of the confidence level. Then next, you get your degree of freedom. Not to worry, colleagues, degree of freedom is just n minus 1. Okay, the number of things we're dealing with. In this case, our n is 7. 7 minus 1, our degree of freedom is 6. Then you go to your T tables. I'll send you this T table. Okay, you come to this T table. Okay, this is the T table. You'll be also be given this in the exam. Right. So the easiest way to read this T table, okay, just come down here and you look what's my confidence level. It is 95%. So this is row 1, row 2, row 3, row 4, row 5, row 6. It's in row 7. Okay, I mean column 7. Confidence level 95%, column 7. Then now look for the degree of freedom. Degree of freedom is 6 here. Degree of freedom is here on the this side here, colleagues. Okay, on the left side here, as you can see. So degree of freedom is 6. So count your columns: 1, 2, 3, 4, 5, 6, 7. So where our degree of freedom and our confidence level intersect at this number 2.57. Okay, that is your critical value. T table. Mm, T table. So where the degree of freedom and the confidence interval intersect, that's your value. Okay. Just remember this: whatever course you're doing, if you're dealing with a table, it's just where the horizontal and the vertical intersect. That is your value. Any questions before we move further? Well, just hold on, hold on, hold on. Which answer after we got which? Oh, after yes, after we got the standard deviation. Yes, yes. No confidence. Or just let me just correct you there. Confidence level will be given to you. The only thing you need to find is just degree of freedom. And if you want even step three, you can bring it in front of step two. Okay. Because the critical value is not dependent on any of the steps. So you can find it at any point. Okay. Yes. So you can continue with your question. What was your question? Get your critical value. Yes. Get critical value from T. Yes. Where they intersect. N represents the number of things being observed or studied or researched. Yeah, so remember, we're dealing with seven products for this company. And, and also in the questions, they'll mention the N, okay? They'll tell you the total number of what is, total number of what is being studied or observed. Yes. Mm. Okay, so the final step, step four, get your standard error. Okay, please go ahead. Okay. But is it okay, madam? Are you following? Any questions? Okay. Mm. All right. So step four, you get the standard error. Do not worry, colleagues. I'll give you some notes on the definitions of all of these things. Okay. Yes. So that maybe if we get accustomed to the process, then so the standard error is just the standard deviation divided by the square root of n. Yeah, that's how you get. the standard error. Okay. So our standard deviation, what was it? 1.13, right? 1.13 divided by the square root of 7. So let's get our calculators. Square root of 7, get it, then divide it by 1.13. One value we're getting. Colleagues, what are we getting? Okay, they're in the same range. Okay, so this is the formula that we're going to use to find our confidence interval. This confidence interval is the range. When we say that sales have dropped for this product, that drop in sales is going to fall in this range. Okay, the drop in sales that we are seeing with this product, it's going to fall in this range. Okay, so to get your confidence interval, it's your average sales difference, which we calculated in step one, plus or minus the critical value, which we got here in step three, multiplied by the standard error, which we've got here. What was the value of our standard error? At 0.426, huh? 0.4271. Okay, let's leave it at 0.43 so that we make life easy. So in other books, that formula which I've written there is going to look like this. X bar plus or minus, you're going to see a T with an alpha over 2. This T with an alpha over 2 just means the critical value. Okay. Yeah. But yeah, the formula is not that, how can I say, it's not that confusing. But yeah. Yes, so this is how the formula is. So the average in the sales differences, which we calculated, this 1.57, 1.57 plus or minus open brackets, our critical value 2.447 multiplied by our standard error 0.43. So first multiply 2.47 times 0.43. Hmm? Okay. 1.052. All right. So since this is a confidence interval, it means we have our lower limit and our upper limit. Because remember, this range is representing the when there's a drop in sales. That drop in sales is going to be in this range. All right. So first you say 1.57, we find our upper limit or yeah, upper bound or upper limit. 1.57 plus 1.052. What do we get? 2.62. So we'll say it's in kwacha because here we're talking about drop in sales. So we're going, our units will be in kwacha. Then 1.57 minus 1.052. 0.5. Okay. So our range is from 0.158 kwacha to 2.62 kwacha. Yes. So when we say, since we are saying it's our 95% confidence interval, so when we say 95% confidence interval, it means if you conduct this test 100 times, 95 times out of those 100, the drop in sales is going to be within this range here, between 0.58 to 2.62. This is the range where you're going to find the drop in sales. If you conduct this test 1,000 times, 950 times, the drop in sales is going to be within this range. And you've got your 15 marks. And you walk out of the exam smiling, knowing that second year is coming. Okay. Once you finish this question in